Right now, a few hundred kilometers above your head, there are people whose bodies are quietly coming apart. Their bones are thinning faster than an 80-year-old's. The backs of their eyeballs are changing shape. Viruses they caught as children are waking up inside their nerves, and not one of them can feel it happening. We're going through every way space takes a human body apart, 9 of them, starting with the first few hours, and ending with what's left of you once it's finished. On the way, we'll meet a man who felt a vacuum working on him from the inside and lived to describe it, and 3 men whose capsule came home perfectly, on target, parachute out, not a mark on it, with nobody alive inside. Space doesn't need a weapon, it just needs you to stay. Number 1. The first 2 liters. We start with the one that begins before the engines have cooled. Gravity spends every second of your life dragging your blood down into your legs. Take it away, and about 2 liters of fluid floats up out of your legs into your chest and skull. Your face swells. Your legs go thin. The crews call it puffy face, bird legs. Then your body misreads the whole thing. All that fluid crowding your chest looks, to your own sensors, like too much blood, so your kidneys start throwing it away, and you can lose a fifth of your plasma in days. Your heart, normally held inside a slightly tight sac, floats free and rounds off by about 9%. A rounder heart is a worse pump. It gets stranger. Astronauts tracked through 6-month missions were destroying around 54% more red blood cells than they would on the ground, 3 million a second instead of 2, and with no downhill for the veins in your neck to drain into. That vein swells and stalls. In one study, blood in some astronauts was flowing backwards, in one case, barely moving at all, which is when it stopped being a curiosity. During a routine ultrasound on the station, doctors found something nobody was looking for, a clot, sitting in an astronaut's neck vein, 400 kilometers from the nearest hospital, and none of it hurts. That's the through line here. Almost nothing on this list announces itself. The first thing that genuinely does hurt is far smaller. It's the ends of your fingers. Number 2. The fingernails. To go outside, you have to be inflated. A spacesuit is a pressure vessel shaped like a person, and once it's pumped up, the fabric goes stiff, closer to a party balloon than a coat, which is fine, until you close your hand. Every squeeze fights the pressure inside the glove for 6 to 8 hours straight, and your fingertips get pressed into the hard thimbles at the ends. Blood flow at the tip drops away, and the nail bed dies from the outside in. The medical word is onycholysis. The plain version is that the nail detaches and comes off. Across 232 NASA astronauts, roughly 1 in 10 had logged fingernail trauma from glove work, and wide hands carried close to a 20% chance of it. Here's how routine that is. Because a loose nail can snag inside a glove halfway through a spacewalk, a few astronauts have simply had their fingernails removed beforehand. The most advanced garment we have ever built, and one of the accepted countermeasures is preemptive removal. Fingernails grow back, at least. The next one doesn't. Number 3. The bones. Your skeleton isn't a fixed object. It's a business, and it audits itself constantly, reinforcing whatever gets loaded, quietly liquidating whatever doesn't. Every step you take is an order for stronger legs. Stop standing on them, and the orders stop. In orbit, weight-bearing bone disappears at roughly 1 to 2% a month, concentrated in the hip, the spine, and the shin, exactly the parts that were holding you up. 6 months up there strips out what a body on Earth takes a decade or more to lose. 17 astronauts had their bones scanned before flight, at landing, and again a year later. A full year after they stopped floating. Most still hadn't got it back, and the ones who'd flown longest recovered the worst. None of them noticed. On Earth, osteoporosis is nicknamed the silent disease for exactly this reason. Bone has no nerve endings to complain with. Fit people in their 40s, walking around inside a skeleton a decade older than the one they launched with. But bone is only the scaffolding. The same pressure that's rearranging their blood is pushing on something far softer. Number 4. The eyes. An eyeball is not a hard object. It's a bag of fluid, held in shape by the pressure inside it. Now put it in a skull where the fluid never properly drains. Over weeks, the pressure behind the eye presses forward and the back of the eyeball flattens, like a football resting against a wall. The disc where the nerve enters begins to swell. Folds appear across the retina, and because the shape of your eye is your prescription, your vision drifts toward farsightedness. People have launched with perfect sight and gone hunting for reading glasses in orbit. It has a name, spaceflight-associated neuroocular syndrome, and it turns up in as many as 70% of astronauts on long missions. Some have come home and never got their old eyes back. Here's what keeps flight surgeons awake. NASA rates it a red risk, near the top of the medical problems standing between us and Mars. And after 15 years of study, they still cannot fully explain the mechanism. You can't engineer your way around something you can't explain. Now notice something. Every item so far has been caused by an absence, one single force going missing. From here on, it's the opposite. From here on, it's what's coming at you. Number 5. The sleeping viruses. Some of the viruses you caught as a child never left. Chickenpox, cold sores, the one behind glandular fever. They went dormant, folded themselves into your nerve cells and your immune cells, and they've been sitting there ever since. What keeps them asleep is a permanent guard patrol run by your own immune system. Spaceflight stands the guards down. Stress hormones climb. The patrolling arm of the immune system gets suppressed, and the viruses do the obvious thing. They wake up. 53% of astronauts on short shuttle flights and 61% on long station missions have been caught shedding live virus in their saliva or urine. It gets worse the longer they stay. More virus, more often, right through to the end of the mission. Most never feel a single symptom, but the shedding doesn't stop the day they land. And that's the uncomfortable part. The risk isn't to the astronaut, it's to whoever meets them at the door, a newborn baby, someone on chemotherapy, which is why a returning crew gets a quarantine window before they're handed back to their own families. And while the immune system is looking the other way, something else is going straight through them, several times a minute. Number 6. The flashes in the dark. On the way to the moon, with the cabin lights out and his eyes closed, Buzz Aldrin started seeing things. Pinpoints, thin streaks, small clouds of light, arriving out of nothing. He wasn't imagining it, and he wasn't alone. Later crews reported it too, so NASA sent up a detector to catch whatever it was. On Apollo 17, wearing that detector for about an hour in the dark, an astronaut logged 17 flashes. Here's what they were seeing. A cosmic ray is an atomic nucleus stripped naked of its electrons and flung across the galaxy at nearly the speed of light, usually by an exploding star. Out past Earth's magnetic field, there's no shelter from them. And when one passes through an eyeball, it can trigger the retina directly, and your brain does the only thing it knows how to do with a signal from the retina. It reports light, so it isn't a hallucination. It's an accurate report. Which brings us to the turn. Your eye is the only organ wired to tell you when it's been hit. The same particles are going through your heart, your bones, and your brain thousands of times a day, and for those, there's no flash. No sensation at all, which leads to the number nobody in this industry enjoys discussing. Number 7. The dose. When the Curiosity rover flew to Mars, it carried a radiation detector sitting roughly where a crew would sit, and simply counted. So we don't have to estimate this. It's measured. Inside the ship, in deep space, the dose came in at about 1.8 millisieverts a day. Over a there and back trip, that's roughly 2/3 of a sievert from the traveling alone. Add a long stay on the surface, where Mars's thin air and missing magnetic field give almost no cover, and the total lands near a full sievert. 1 sievert is the entire career limit the European Space Agency sets for an astronaut, not per mission, per lifetime. So one trip to Mars spends a whole career's allowance, and the accepted arithmetic is that a sievert lifts your odds of dying of cancer by around 5%. And this is the only item here with no clean engineering answer. These are heavy nuclei moving at a serious fraction of light speed. A spacecraft hull barely inconveniences them. Stopping them takes mass, meters of water or rock. Worse, a thin shield can make things uglier because one particle striking aluminium sprays out a shower of fresh radiation on the far side. For now, the only real countermeasure is the clock. Go faster, be out there less. Everything so far has taken months. The next one takes 14 seconds. Number 8. The 14 seconds. The 14th of December, 1966. Houston. A NASA technician named Jim LeBlanc is sealed inside a prototype Apollo suit, inside a chamber pumped down to near vacuum, testing it for leaks. Then a hose disconnects. In under 10 seconds, his suit falls to 1/10 of a pound per square inch. Effectively nothing. What he remembered afterwards was the saliva on his tongue starting to bubble. That isn't a figure of speech. Water's boiling point falls as pressure falls, and at that pressure it boils at body temperature. He was unconscious in about 14 seconds. A colleague was already forcing pressure back into the chamber, and 87 seconds later he came round, with aching ears and no lasting damage, the only person ever to survive it. So let's kill the film version while we're here. You don't explode. Your skin is a tough sealed bag, and it holds. Your blood doesn't boil because it's inside a closed pressurized system. Only the wet surfaces exposed to the vacuum can do that. You don't even freeze quickly. A vacuum has nothing in it to carry your heat away, so you'd cool over hours. What actually kills you is far more ordinary: suffocation. You get roughly 15 seconds of useful consciousness, the oxygen already sitting in your brain, and then you're gone. LeBlanc lived on a margin of seconds because someone was standing right there with a hand on the valve, which is precisely the margin 3 men did not have. And the last one, the 3 who came home: Georgy Dobrovolsky, Vladislav Volkov, Viktor Patsayev. In June 1971, they became the first human beings to properly live aboard a space station. 23 days on Salyut 1, a world record. Then they undocked and started home. Their capsule had to separate from the module above it, and 12 small explosive charges were meant to fire in sequence to do it. They all fired at once. The jolt traveled through the structure and knocked a valve open, a small pressure equalizing valve designed to crack open a few kilometers above the ground so the cabin could match the outside air before landing. It opened at 168 kilometers in space. The cabin emptied in under 2 minutes, and there was nothing they could do because there were no pressure suits aboard. 3 seats in that capsule left no room for them, and then the machine did everything perfectly. Textbook re-entry, parachute out on schedule, a soft landing, on target in Kazakhstan. No fire, not a mark on it. The recovery crew ran across the steppe, hauled the hatch open, and found that the flight had come home without its crew. They are still the only 3 human beings ever to die in space, and every Soyuz flown since has carried pressure suits for launch and landing. And here's the last thing, the part that makes this catalog different from every other one in the archive. On Earth, a body gets recycled. That's what bacteria and insects and water and oxygen are for. Space has none of them. Expose a body to vacuum, and the water in the outer tissue leaves within minutes, and the bacteria on the skin die with it. So nothing takes you apart. In sunlight, you'd freeze dry. In shadow, you'd freeze solid. Either way, preserved, still recognizably a person, thousands of years from now, in the same posture, traveling in the same direction. Every other entry on this list is space slowly taking a human body apart. The last one is space refusing to let go of it. All of it is happening to somebody tonight, a few hundred kilometers above your roof, to people who put their hands up and volunteered. And the strangest specimen in the whole catalog isn't any of the damage. It's that knowing every line of this, in exactly this much detail, we still keep sending them. If you made it all the way to the 3 who never came home, comment Soyuz so I know you went the distance. Leave a like so the algorithm knows you survived it. The next specimen is already on the shelf.